In this video, we will compare the dramatic performance differences between Python lists and NumPy arrays with some simple examples. As you will see, using NumPy for numerical computations can lead to significant performance improvements, especially with large datasets. Firstly, let's try to get the sum of a list of numbers with for loop, which is a common action in practice. It takes about 3 seconds for a list of 50 million numbers on my computer. If you want to test it by yourself, you may want to change the list size so it won't take too long for you. Actually, there is a built-in sum function in Python that can be used to get the sum of a list of numbers directly. Surprisingly, the sum function is 10 times faster than using for loop to sum up the elements of a list, which means the sum function is optimized for summing actions. Now let's compare the performance of the summing calculation with the NumPy package. You would have to install it first before using it. The NumPy package contains functions for various mathematical calculations. We first need to create a NumPy array, which can be created directly or converted from a Python list. Then we can call the sum function from NumPy to sum the elements of an array. As demonstrated, the performance is more than 10 times higher than with the built-in sum function on a list. Let's check another example that multiplies each element of a list or NumPy array by a scalar value. As shown in this example, using NumPy arrays for this type of mathematical calculation is not only much faster, but also much simpler. Finally, let's check an example of element-wise addition which adds the elements of two lists or arrays together. As expected, using NumPy arrays is again both much faster and much simpler. So why NumPy is much faster than native Python lists? Firstly, NumPy operations are vectorized, meaning they are designed to process entire arrays of data at once rather than element by element. Secondly, NumPy's underlying implementations are written in C, which is compiled and runs much faster than interpreted Python code. And finally, NumPy arrays are stored in contiguous memory blocks, which enhances cache performance and reduces memory overhead compared to Python lists. Therefore, using NumPy for numerical computations can lead to significant performance improvements, especially with large datasets. Whenever possible, leveraging NumPy's array operations and mathematical functions is preferable over using Python for loops for numerical tasks. This is it for this video. Thank you for watching. If you enjoyed the video, please subscribe to my channel for more content.